Okay, we just got done going over the basics of functions. You may recognize this slide right here. The next thing that we're going to do is learn how to verify inverses. So if you're ever asked to verify whether it's an inverse, this is how you do it, and it's actually very, very simple. In order to verify that two functions are inverses of one another, you'll need to demonstrate exactly what the definition says. Remember, the definition said that f of f inverse equals x and f inverse of f equals x. So every single time that you do it, you're going to have to show both of those composite functions equaling x. And since we just got done doing inverse or composite functions in chapter 1.8, this is a piece of cake. Let's start with an example right away. Verify that f and g are inverses. F of x equals 5 over x minus 2. G of x equals 5 over x plus 2. Pay attention to the notation. It's not 5 over x plus 2. It's 5 over x plus 2. All right, so the first thing that we do is we figure out what f of g of x is. All right, so that means we have to take g of x and plug it in for that x. And that's going to look like this. And then we have to simplify it. Well, if I have 5 over x plus 2 minus 2 on the bottom, those two things are going to end up canceling each other out. So that takes me to this. And then 5 over x, well, when you have a compound fraction like this, you need to multiply by the reciprocal of the denominator. Cancels all down there, 5's canceled there, and what are you left with? X. So it works one way. It is possible for a function to work one way and not the other. So we always have to check the other as well. What I mean is we have to figure out g of f of x. So we need to plug f into g, which will look like this. All right, and using the same logic that we did on the 5 over x with that composite function, you multiply by the reciprocal of the denominator, and you should get this. And those 5's cancel. And x minus 2 plus 2 is x. So now we know, yep, they are inverses. All right, one more example. And I'm going to have you do this one on your own if you can. F of x equals 4x minus 1, and g of x equals x plus 1 all over 4. So I'd like you to pause the video, verify that both composite functions result in x. All right, your steps should look like this. When we plug g into f, it would look like this. The 4's cancel, leaving it with x plus 1 minus 1, giving us x. When we plug f into g, we have 4x minus 1 plus 1 in the numerator, and just 4 in the denominator. Plus 1 minus 1 gives us just 4x. 4x over 4 is just x. All right, so that's how you verify inverse functions, and that is the end of this video.